There is a deep and profound silence that blankets the cosmos, a quiet that stretches between the stars for light years. Within this immense silence, we have always believed we were observing the entirety of existence, the complete and total story of the universe. We pointed our telescopes at the darkness and meticulously cataloged the light, mapping the grand architecture of galaxies and nebulae. Every law of physics we discovered seemed to confirm our understanding, reinforcing the solid foundation upon which our reality was built. But the universe is older and more subtle than we can possibly imagine, and its greatest truths are not always written in the glaring light of stars. Sometimes, the most important secrets are hidden in the quietest of places, in the subtle deviations from what we expect to see. For decades, small inconsistencies have been gathering at the edges of our knowledge, like faint whispers in a vast, empty room. Astronomers would note the anomalies, file them away as measurement errors or unexplained phenomena, and continue with their work. A galaxy spinning too fast for the matter it contained, a distant supernova appearing dimmer than it should, an inexplicable chill in the cosmic dawn. These were treated as isolated puzzles, disconnected problems to be solved by the next generation of thinkers, with better instruments and equations. But what if they were not separate puzzles at all? What if they were all pieces of a single, much larger and more profound picture? What if these were the faint fingerprints of something else, a hidden architecture just beneath the surface of the reality we perceive every day? The notion that the universe is hiding something from us is not new. It is a thought that has haunted philosophers for millennia. They imagined worlds behind worlds, realities layered upon our own, a grand design whose full scope was forever beyond our mortal comprehension. Yet, science demanded evidence, data that could be measured and verified, something more tangible than philosophical speculation or ancient myth. And so, we continued to look, to listen, to build ever more sensitive instruments designed to parse the subtle language of the cosmos. We sent probes into the void, extending our senses beyond the cradle of our world, hoping to glimpse something new and undiscovered. We built great arrays of radio dishes, listening not for messages, but for the faint, residual echoes of the universe's very first moments. And it is there, in the oldest light in all of existence, that the first concrete clue has finally been found by those who knew how to look. It is not a structure or an object, not a planet or a star, but something far more fundamental, a pattern that should not exist. A subtle, large-scale arrangement in the fabric of space-time that defies our most fundamental and cherished theories about the universe's origins. For the first time, we have found a deliberate-looking signature, a piece of evidence that suggests the cosmos is not as random as we believed. It implies that the universe we inhabit is perhaps only one side of a much larger, more complex, and deeply hidden structure. The implications of this are staggering, forcing us to reconsider everything we thought we knew about our place in the grand cosmic narrative. The story of reality is not finished. In fact, it now appears that we have only been reading the introduction for all of human history. A new chapter has begun, prompted by a discovery that forces us to look not at the light, but at the subtle patterns within the darkness. What we have found is a crack in the edifice of modern cosmology, a glimpse through the veil of perceived reality. It suggests that the vast emptiness of space is not empty at all, but is instead filled with an unseen influence that shapes everything. This influence is not made of matter or energy in any form that we can currently recognize or directly interact with. Instead, its existence is inferred, like the wind, which is seen only by the way it moves the leaves on the trees. We are now seeing the cosmic leaves move in a way that our theories of wind can no longer adequately explain to us. The search is no longer for new planets or distant galaxies, but for the very nature of this hidden cosmic framework itself. It forces upon us a profound question. Is the universe a natural occurrence, or is it something more akin to a designed system? This discovery does not provide an answer, but it gives this ancient philosophical question a new and startling scientific foundation. We must now become cosmic archaeologists, digging through layers of data to uncover the truth of what our universe is truly hiding. The story begins with the simple observation that the universe, on its grandest scales, is far more organized than it has any right to be. The laws of physics predicted a cosmos born of chaotic chance, a random scattering of matter and energy that would be largely uniform. Yet what we observe is a delicate, web-like structure of galaxy clusters and superclusters, separated by impossibly vast and empty voids. The existence of this cosmic web has always been a puzzle, but we attributed it to the slow, patient work of gravity over billions of years. Now, a newly uncovered alignment within this structure suggests another, more powerful organizing principle has been at work since the beginning. This principle is invisible, undetectable, and yet its influence is written across the entire observable universe for anyone with the eyes to see it. It is a discovery that reframes humanity not as the universe's observers, but perhaps as inhabitants of a far grander and more mysterious architecture. The equations that describe our universe have always had gaps, places where the numbers didn't quite add up, without adding mysterious components. We called them dark matter and dark energy, placeholders for our ignorance, convenient fictions to make the math balance out correctly. But this new finding suggests they are not just missing components. They are the shadows of a much larger, unseen reality. A reality that governs the shape of our own, the way a skeleton, unseen beneath the skin, governs the form of a living creature. We are on the verge of mapping this cosmic skeleton, of understanding the hidden logic that underpins all of existence. The journey ahead will require us to abandon our most fundamental assumptions about space, time, and the nature of information. We must learn to think not like astronomers, but like cryptographers, attempting to decipher a code written into the very fabric of space-time. The secret is out there, waiting in the silence between the stars, and we have finally, after all this time, found the key. The discovery began not with a sudden eureka moment, but with the painstaking analysis of the cosmic microwave background radiation, the faint, omnipresent afterglow of the Big Bang. This ancient light, which has traveled for over 13 billion years to reach us, is not perfectly uniform. It contains minuscule temperature fluctuations, the fossilized remnants of the universe's infancy. Cosmologists believed these fluctuations, these seeds of all future structure, should be entirely random, conforming to the principles of quantum chaos that governed the primordial state. But as our mapping resolution improved, a statistical anomaly of profound significance emerged from the noise. Certain large-scale patterns in the CMB were not random at all. Instead, they appeared to be aligned with the ecliptic plane of our own solar system, a feature colloquially termed the axis of evil, a name that belies its true, awe-inspiring significance. This alignment is statistically improbable to an almost comical degree, a 1 in 100,000 chance occurrence if the standard model of cosmology is correct. It suggests a deeply unsettling connection between the largest observable structure in the universe and the local arrangement of our tiny solar system. It's as if the entire cosmos were somehow aware of the orientation of the Earth as it orbits the Sun. For decades, scientists sought to explain it away as a systematic error in our instruments, a foreground contamination from the Milky Way, or a statistical fluke we would eventually understand. However, repeated, independent observations by different satellites like WMAP and the Planck spacecraft have only confirmed its existence, strengthening the statistical significance and deepening the impossible mystery of its origin and meaning. The search for an explanation forces us into the deepest and most abstract realms of theoretical physics, far beyond the comfortable confines of established science. One emerging hypothesis posits that what we are observing is not a flaw in our understanding of the early universe, but rather the first empirical evidence for a concept known as cosmic anisotropy. This is the idea that the universe is not the same in all directions, that there are preferred axes or orientations woven into the very fabric of space-time. Such a property would violate the cosmological principle, a fundamental assumption that has underpinned all of modern astronomy. This principle states that on large scales, the universe is homogeneous and isotropic, meaning it looks roughly the same everywhere and in every direction. The CMB alignment is a direct, observational challenge to this foundational pillar of our cosmic model. To understand what could cause such a preferred direction, we must consider the possibility that our three-dimensional universe is merely a membrane, or brain, floating within a higher dimensional space known as the bulk. In this view, the Big Bang was not the beginning of everything, but perhaps the result of a collision between our brain and another, an event that would have sent shockwaves rippling through space-time. The axis of evil alignment could be a residual scar from this cataclysmic, dimension-spanning event, a kind of cosmic grain or texture imprinted upon our universe at the moment of its creation. The direction of this alignment would then represent the vector of that ancient impact, a permanent record of our universe's violent birth within a far larger, unseen hyperspace that we can never directly access or perceive. This concept intersects with another profound mystery: the nature of dark matter and dark energy, which together constitute over 95% of the universe's mass energy content. We cannot see them or interact with them, yet we observe their gravitational effects everywhere. Dark matter provides the unseen scaffolding that holds galaxies together, preventing them from flying apart. Dark energy is the enigmatic force driving the accelerated expansion of the universe. In a brain world scenario, these dark components might not be substances within our universe at all. Instead, they could be the gravitational influence of matter and energy existing in the higher dimensional bulk, leaking across the membrane into our own spacetime. A kind of cosmic shadow cast by a reality we cannot see. The new discovery is what links these disparate ideas together. Recent ultra-precise maps of the distribution of galaxies on the largest scales, the cosmic web, have revealed another, even more startling alignment. The rotational axes of quasars, the supermassive black holes at the centers of ancient galaxies, are not randomly oriented. Across billions of light years, these unimaginably massive objects show a coherent alignment, spinning in synchrony along vast filaments of the cosmic web. More astonishingly still, this large-scale quasar alignment seems to point in the same general direction as the axis of evil found in the cosmic microwave background. This suggests the organizing principle, the hidden influence, is not just a relic from the Big Bang, but an active, ongoing force that has been shaping cosmic evolution for billions of years. This finding transforms the universe from a collection of objects passively evolving under gravity into something more akin to a single, interconnected system. The information dictating the spin of a quasar in one corner of the cosmos appears to be correlated with the spin of another, billions of light years away, and both are linked to a primordial axis established at the dawn of time. This level of coherence defies explanation by any known force. Gravity is far too weak to create such alignments over these cosmic distances, and the light speed limit prevents any causal connection between these objects. It is as if the entire universe is responding to an invisible, overarching framework, a blueprint that was laid down at the very beginning and continues to guide the formation of the largest structures we can observe. The implications lead us to an even more radical and mind-altering possibility: the holographic principle. First proposed as a solution to the black hole information paradox, this principle suggests that the information content of any volume of space can be fully described by a theory that lives on the boundary of that region. In its most extreme form, it posits that our entire three-dimensional universe could be a holographic projection of information stored on a two-dimensional surface at the cosmological horizon. If this were true, the non-random patterns we observe, the large-scale alignments and cosmic coincidences, might be the result of the underlying physics of this lower-dimensional source code, manifesting as correlations in the projected 3D image we perceive as our reality. In this holographic paradigm, the hidden something is the code itself. The universe isn't just described by information, it is information. The strange coherence we see is not the result of forces acting across space, but of the logical structure of the underlying informational substrate. It's analogous to finding that certain pixels on a vast television screen are correlated. The explanation isn't that the pixels are communicating with each other, but that they are all being controlled by a single, coherent video signal. The discovery of these cosmic alignments, therefore, might be the first time we've noticed the pixel structure of reality, a glimpse of the computational process that is generating the universe from a deeper, more fundamental level of existence that is not spatial in nature. This information-theoretic view of the cosmos also offers a novel perspective on dark matter and dark energy. They might not be physical substances, but rather components of the cosmic algorithm itself. Dark matter could represent the computational overhead required to render the complex gravitational structures of galaxies, a kind of distributed processing that appears to us as mass. Dark energy, the force driving cosmic expansion, could be the algorithm's clock speed, or a fundamental refresh rate, pushing the boundaries of the simulation outward. The universe in this sense isn't just hiding something, it is a grand illusion, a projection whose true nature is purely mathematical and informational, a reality built from bits rather than particles. Let us return to the cosmic web, the vast, filamentary structure of galaxies. The discovery of aligned quasar spins within this web provides a powerful testing ground for these ideas. Supercomputer simulations of cosmic evolution based on standard physics failed to reproduce this level of large-scale coherence. However, when models incorporate anisotropic principles or non-local connections, as one might expect in a holographic system, these alignments begin to emerge naturally from the simulations. It appears the universe possesses a form of memory or long-range order that is not accounted for in our current understanding. The past state of a region of space seems to influence the future state of a distant region in a way that transcends the speed of light, a phenomenon that is impossible in classical physics, but is a hallmark of quantum entanglement and informational systems. This leads us to question the very nature of physical law. We have always assumed that the laws of physics are constant, universal, and absolute, applying equally everywhere and at all times. But what if they are not? What if the laws themselves are emergent properties of the underlying informational system, more like habits than unbreakable edicts? The cosmic alignments could be a sign that the rules of the universe were different in its early stages, or that they vary depending on one's location within the larger hyperstructure. The universe might not be a single, monolithic entity governed by one set of laws, but a patchwork of domains with subtly different physical properties, all orchestrated by a deeper logic we have yet to discover. Consider the fine-tuning problem, the observation that the fundamental constants of nature, the strength of gravity, the charge of an electron, the cosmological constant, are all exquisitely balanced to permit the existence of complex structures like stars, planets, and life. A slight change in any one of these values would result in a universe that is sterile and empty. The traditional explanation has been the anthropic principle, which states that we observe this fine-tuning simply because we couldn't exist to observe it otherwise. But the discovery of a hidden organizing principle suggests an alternative. Perhaps the constants are not random at all. Perhaps they are determined by the structure of the underlying system, set to these specific values as part of a larger, coherent design. This new finding, this alignment of the ancient and the vast, serves as an empirical anchor for these otherwise purely speculative ideas. It is a thread we can pull on, a clue that connects the cosmic dawn with the modern galactic web, and both with the deepest mysteries of fundamental physics. It suggests that the universe is not just a stage on which the drama of existence unfolds, but an active participant with its own internal logic and structure. The something that the universe is hiding, then, is its own nature. It has been hiding the fact that it is not a random collection of matter and energy, but a coherent, organized, and deeply interconnected system whose operating principles we are only just beginning to dimly perceive through the static. To probe this further, scientists are now designing new kinds of astronomical surveys. Instead of just mapping the positions of galaxies, they will meticulously chart their rotational orientations and the polarization of their light. They are looking for more examples of these cosmic alignments, hoping to build a comprehensive map of this hidden grain in the universe's fabric. This is a new form of astronomy, one that focuses not on objects, but on relationships and correlations across vast, causally disconnected regions of space-time. It is a search for the syntax and grammar of the cosmos, the rules that govern the arrangement of its constituent parts, in the hope of one day being able to read the language in which reality itself is written. The philosophical shift this represents is monumental. For centuries, science has operated under the principle of mediocrity, the idea that we and our planet occupy no special place in the universe. But the alignment of the largest cosmic structures with our own local solar system plane directly challenges this notion. It does not necessarily mean we are at the center of the universe, but it could imply a deeper connection between the conditions necessary for life and the fundamental structure of the cosmos. Perhaps the very same principles that organize the universe on large scales also guided the formation of our solar system, making our particular orientation not a coincidence, but a natural outcome of a universal, symmetry-breaking process that we are now finally detecting. This deeper organizing principle might manifest as a subtle force we have not yet detected. Some theoretical physicists are exploring the possibility of a vector field that permeates all of space-time, similar to a magnetic field. This cosmic field would have a preferred direction, established during the inflationary epoch just moments after the Big Bang. As the universe expanded, this field would have gently nudged the formation of structure, aligning the cooling plasma in the early universe and later guiding the angular momentum of collapsing gas clouds that would form galaxies and quasars. This would explain both the CMB anomaly and the quasar alignments, with a single elegant mechanism, transforming our picture of the vacuum of space from an empty void into a dynamic, structured medium. Let us explore the concept of information in more depth, for it seems to be at the heart of this mystery. In physics, information is not an abstract concept. It is a physical quantity, as real as mass or energy. The Bekenstein bound, for example, sets a hard limit on the amount of information that can be contained within a given region of space. The recent discovery of these cosmic correlations suggests that information in the universe is being processed and stored in a far more efficient and globally coherent way than previously imagined. It hints at a form of universal computation where every particle and every field is part of a single vast calculation unfolding over billions of years, a calculation whose purpose and ultimate output remain entirely unknown to us. This computational perspective offers a fascinating reinterpretation of the flow of time. We perceive time as a linear progression from a fixed past to an open future, but in an information-based reality, this could be an illusion. The entire history of the universe, past, present, and future, might exist simultaneously as a complete block of information, a block universe. Our consciousness would then be merely a focal point, a reader, moving through this static data block and experiencing it sequentially as the passage of time. The alignments we see could then be explained as boundary conditions or consistency checks within the overall data structure, ensuring that the cosmic narrative is coherent from beginning to end, just as an author ensures consistency throughout a complex novel. The finding forces a convergence of cosmology, quantum physics, and computer science. The universe begins to look less like a grand clockwork machine and more like a quantum computer. The strange, non-local alignments are reminiscent of quantum entanglement, the spooky action at a distance that so troubled Einstein, where two particles remain connected no matter how far apart they are. What if the entire universe was born from a single, entangled quantum state? Then, in a sense, everything would still be connected to everything else. The spin of a distant quasar would not be independent of its neighbors, because they are all part of the same original quantum wave function. Their properties correlated in ways that defy classical intuition but are perfectly natural in the quantum realm. This concept of cosmic entanglement would mean that the universe is fundamentally non-local. An event happening here could have instantaneous correlations with an event on the other side of the cosmos, not because a signal travels between them, but because they are not truly separate entities to begin with. They are different expressions of a single, underlying quantum reality. The hidden layer of the universe, therefore, would be this quantum substrate, a realm where our notions of distance and separation cease to have meaning. The alignments we observe in our three-dimensional space would be the macroscopic shadows of this profound, underlying quantum unity, the first evidence that our universe is far more holistic and interconnected than we ever dared to dream. This discovery also breathes new life into the simulation hypothesis, the idea that our reality is an artificial construct. While this has long been a subject of philosophical debate, the discovery of a preferred direction or an underlying grid-like structure provides the first piece of potentially testable empirical evidence. An artificial simulation created on a parent computer might very well have artifacts of its underlying processing architecture. The cosmic alignments could be a manifestation of this architecture, akin to the directional grain in a block of wood or the raster scan lines on an old monitor. We might be observing the fundamental pixel resolution or the coordinate system of the simulation in which we exist, a glitch in the matrix on a cosmological scale. If we inhabit a simulation, the question of the programmer or simulator arises. However, from a scientific perspective, this is not the most relevant question. The immediate task is to study the physics of the simulation itself. By mapping these alignments and searching for other artifacts, we could potentially deduce the rules and limitations of our reality's operating system. We could learn about the nature of the computational substrate, whether it is classical or quantum, and perhaps even find ways to exploit its properties. The universe would transform from a natural phenomenon to be studied into a piece of software to be reverse engineered. a truly paradigm-shattering shift in the history of science and human thought. Whether the cause is a higher dimensional collision, a holographic projection, cosmic entanglement, or an artificial simulation, the conclusion remains the same. The universe we see is not the fundamental reality. It is an emergent phenomenon, a surface layer resting on a deeper, hidden framework whose nature is profoundly different from anything we know. The discovery of these cosmic alignments is our first window into this deeper reality. It is a message, not in a language of symbols or numbers, but in the very structure of space-time itself. It is a message that tells us our exploration of the cosmos has just begun, and that the greatest mysteries lie not in the spaces between the stars, but in the very foundations of existence. The psychological impact of this unfolding revelation is difficult to overstate. We are faced with the tangible possibility that our universe is a small part of a much larger megastructure, or perhaps not even real in the conventional sense. This can induce a profound sense of cosmic vertigo, a feeling of insignificance in the face of such an incomprehensible scale. Yet, it can also inspire a deep and meditative awe. It means that reality is infinitely more mysterious and wonderful than we had conceived. It places humanity at the threshold of a new intellectual renaissance, where the boundaries between physics, metaphysics, and information theory dissolve into a unified search for the ultimate nature of what is. Let us contemplate the structure of the cosmic web in greater detail. It is comprised of vast, galaxy-rich filaments stretching for hundreds of millions of light-years, surrounding immense, nearly empty regions known as voids. The new data shows that galaxies within these filaments tend to have their rotational axes aligned with the filament's direction, like beads spinning on a string. This alignment is stronger than predicted by gravity alone. The hidden influence appears to be imparting a collective angular momentum to structures on an unprecedented scale, a form of cosmic choreography that suggests a top-down organizing principle rather than the bottom-up gravity-driven formation that has been our standard model for decades. This top-down organization hints that the initial conditions of the universe were not as random as we thought. Perhaps the quantum foam from which space-time emerged was not entirely chaotic, but contained within it a pre-existing structure or pattern. This pre-geometric information would have guided the inflationary expansion, stretching this primordial pattern across the entire observable cosmos. The cosmic web, the CMB alignments, and the synchronized quasars would then all be macroscopic relics of this initial ordered state. This something that is hidden would be the set of rules that governed the universe before the Big Bang, a physics that precedes space-time itself and from which our own physical laws are merely a secondary consequence. To search for this pre-Big Bang physics, scientists are studying the voids, the great cosmic deserts. These regions are not entirely empty. They are filled with a faint web of dark matter and a few lonely dwarf galaxies. The theory suggests that if the universe has a hidden directional grain, its effects should be most pristine and observable within these voids, where the messy gravitational interactions of large galaxies are absent. Future telescopes will be tasked with mapping the faint wisps of hydrogen gas within these voids, looking for subtle alignments or pressure variations that could betray the presence of a cosmic vector field or the influence of higher dimensions, turning these empty spaces into the cleanest laboratories for studying the universe's hidden architecture. The concept of a hidden architecture resonates deeply with the ancient philosophical idea of the logos, a universal principle of order and reason that permeates the cosmos. Early thinkers imagined a divine logic guiding the chaotic world of matter, a hidden set of rules that brought harmony to the universe. The discovery of these cosmic alignments could be seen as the first scientific evidence for such a principle. It is not a conscious or intelligent designer, but rather an inherent mathematical or informational logic woven into the fabric of reality. The universe, it seems, possesses an innate tendency towards large-scale order and coherence, a property that is as fundamental as gravity or electromagnetism, but which has remained invisible to us until now. This new paradigm forces us to reconsider the nature of scientific discovery itself. We have always acted as passive observers, collecting data from a universe that is indifferent to our existence. But if the universe is an interconnected informational system, then the act of observation might not be so passive. Quantum mechanics has already taught us that observing a system can change its state. On a cosmic scale, could our increasingly sophisticated observations of the universe be subtly influencing its evolution? Could the very act of mapping these hidden structures be part of the cosmic algorithm's unfolding, a feedback loop, where the universe, in a sense, begins to observe itself through us? Consider the mystery of galactic rotation curves, which provided the first evidence for dark matter. Stars in the outer regions of spiral galaxies orbit far too quickly for the amount of visible matter. The standard explanation is a vast, unseen halo of dark matter providing the extra gravitational pull. But in the context of a hidden cosmic framework, an alternative emerges. Perhaps space-time itself is modified within and around galaxies by this underlying field. The laws of gravity might not be universal, but could be affected by the local density of this hidden architecture. The fast-spinning stars would then be evidence not of missing matter, but of a deeper, more complex theory of gravity that incorporates the influence of this unseen cosmic substrate. This idea, known as modified Newtonian dynamics, or MOND, has long been a fringe theory, but the discovery of large-scale alignments gives it new plausibility. If a universal field can align quasars across billions of light-years, it is conceivable that the same field could intensify its effects in the denser regions of galaxies, altering the behavior of gravity in just the right way to explain the rotation curves without invoking the need for dark matter. The hidden something would then be a modification to the laws of physics themselves, a deeper layer of reality that manifests as both large-scale cosmic order and localized gravitational anomalies, unifying two of the biggest mysteries in modern cosmology under a single elegant theoretical umbrella. The search for this hidden reality is the ultimate expression of the human desire to understand our origins and place in the cosmos. We are moving beyond the mapping of our local neighborhood to questioning the very nature of the map itself. We are probing the foundational assumptions upon which our entire scientific worldview is based. Each new piece of data, each new alignment found in the cosmic web, is another clue, another breadcrumb, leading us deeper into a mystery far grander than any of our ancestors could have ever imagined. We are like cartographers of old, who, after mapping the familiar continents, suddenly found evidence of an entirely new, hidden world, just beyond the horizon of their understanding. It is a humbling and profoundly meditative realization. Every atom in our bodies, every planet, every star, is participating in this grand, silent choreography. The universe is not a chaotic accident, but a place of deep and subtle order. The hidden something is not an object or a place, but a principle. A principle of connection, of coherence, of an underlying unity that binds the cosmos together across unimaginable distances and incomprehensible timescales. And we, on our small blue world, have finally built the tools and developed the sight needed to catch the first fleeting glimpse of its magnificent design, forever changing our relationship with the silent, starry night. The phenomenon of gravitational lensing offers another powerful tool to probe this hidden architecture. When light from a distant quasar passes by a massive galaxy, its path is bent, creating multiple images of the quasar. By studying the precise time delays between the flickering of these different images, we can measure the expansion rate of the universe. Recently, discrepancies have arisen between the expansion rate measured this way and the rate inferred from the cosmic microwave background. This Hubble tension could be another manifestation of the hidden structure. The underlying cosmic grain might be subtly altering the path of light over billions of years, creating a systematic deviation that our current models, assuming a perfectly smooth spacetime, cannot account for. Imagine spacetime not as a smooth sheet of rubber, but as a fabric with a distinct weave and texture. The threads of this weave would be the filaments of the hidden cosmic framework, the vector field that permeates existence. Light traveling along the weave would behave differently than light traveling against it. The Hubble tension might be the first time we've measured the difference, the first tangible sign that space-time has a microscopic structure that affects the propagation of energy on a macroscopic scale. This would imply that the vacuum of space is a physical medium with properties like birefringence, similar to a calcite crystal, which splits a single ray of light into two. The universe itself might be a giant cosmic crystal with a preferred optical axis. This directional property of spacetime could also solve the matter-antimatter asymmetry problem, one of the most stubborn puzzles in physics, the Big Bang should have produced equal amounts of matter and antimatter, which would have annihilated each other, leaving a universe filled only with light. Yet we live in a universe made almost entirely of matter. A theory known as baryogenesis requires a violation of charge parity symmetry. The existence of a fundamental cosmic vector field, a preferred direction in the universe, would naturally provide this required symmetry violation. The axis of evil would then be more than a curiosity. It would be the reason for our very existence, the primordial asymmetry that allowed matter to triumph over antimatter at the dawn of time. Let us return to the holographic principle and the nature of information. If our reality is a projection, then the concept of empty space becomes an illusion. Every cubic centimeter of the vacuum, even the most profound void between galaxies, would be teeming with the underlying information that projects reality. The holographic principle, combined with quantum field theory, suggests that the vacuum contains a staggering amount of energy, the so-called vacuum energy. Our cosmological models require this energy to be almost precisely cancelled out, a fine-tuning problem of 120 orders of magnitude. But if the vacuum is the computational substrate, this energy might not be a bug, but a feature. It could be the raw processing power of the cosmic engine that generates our reality. The hidden framework, in this view, is the system architecture that organizes this vacuum energy, preventing it from collapsing our universe and instead harnessing it for the purpose of cosmic computation. The alignments we see are the macroscopic effects of the logical operations happening at the Planck scale, the smallest possible level of reality. We are not just living in the universe. We are living on the output screen of a vast natural computer whose operations are so fundamental that they manifest as the laws of physics themselves. The something that is hidden is the software, the cosmic operating system running on the hardware of vacuum energy, and we have just discovered our first clue about its user interface. This computational viewpoint also provides a potential explanation for quantum weirdness. The principle of superposition, where a particle can be in multiple states at once, could be seen as a calculation that has not yet been finalized. The act of measurement, or observation, would be the moment the system finalizes that part of the calculation and renders a definite result, causing the wave function to collapse. Entanglement, the connection between distant particles, would simply be the result of two parts of a calculation being linked by the same line of code, so that when one value is determined, the other is instantly updated as a logical necessity of the program's structure, regardless of their spatial separation in the rendered output. This profound recontextualization of reality requires a new language, a new way of thinking. The causal mechanistic worldview that has dominated science since Newton is no longer sufficient. We must begin to think in terms of information, computation, and emergent complexity. The universe may not be a story of particles and forces, but a story of evolving information. The discovery of the cosmic alignments is the first sentence we have been able to read in this new cosmic language. It is a sentence that challenges us to look deeper, to question everything, and to embrace a reality that is far more interconnected, mysterious, and ultimately computational than we ever thought possible. Let's consider the scale of these alignments. The coherent spin of quasars across billions of light-years is particularly challenging. These ancient hyperluminous galactic cores are separated by distances so vast that light has not had time to travel between them over the entire age of the universe. This definitively rules out any classical causal mechanism. It is a clear, unambiguous signal of non-locality. This discovery elevates what was once a purely theoretical concept in quantum mechanics to an observed phenomenon on a cosmological scale. The universe is not a collection of separate objects interacting locally. It is a single, unified entity whose distant parts are correlated in a way that transcends our conventional understanding of space and time. This forces us to reevaluate the nature of space-time itself. In Einstein's theory of general relativity, space-time is the dynamic stage on which events unfold. But what if space-time is not fundamental? What if it is an emergent property of a deeper network of quantum information? Some theories of quantum gravity, like loop quantum gravity, propose that space is not continuous, but is made of discrete, quantized atoms of spacetime. The cosmic alignments could be a macroscopic manifestation of the structure of this underlying quantum network, a kind of crystalline pattern in the fabric of reality itself, where the connections between the atoms of spacetime are not entirely random but follow a coherent, large-scale design. Imagine this quantum network as an intricate, multidimensional web. our three-dimensional space would be just one aspect of its complex topology. In this deeper reality, two quasars that appear billions of light-years apart to us might be directly adjacent in the quantum network, connected by a wormhole or a link that bypasses our spatial dimensions entirely. Their synchronized spins would then be a perfectly natural, local interaction in the underlying information space. The hidden something, therefore, is the true connectivity map of the universe, a reality where distance is not defined by a ruler, but by informational proximity. We are perceiving only a shadow of this true structure, a flattened projection that creates the illusion of vast, empty distances. The implications for the search for extraterrestrial intelligence are profound. We have traditionally searched for signals traveling through three-dimensional space at the speed of light. But if the universe is fundamentally non-local and information-based, this might be the wrong approach. A sufficiently advanced civilization might not communicate with radio waves, but by directly manipulating the underlying informational substrate of reality. Their messages would not be signals traveling from point A to point B, but coordinated changes in the state of the cosmic wave function itself. Is it possible that the large-scale coherence we are just now discovering is not a natural phenomenon, but a sign of cosmic engineering on an unimaginable scale, a message not in the universe but of the universe? This is, of course, highly speculative, but the data forces us to consider such possibilities. If the universe is a computational system, then it is not a logical leap to suggest that it could be programmed or manipulated. The fine-tuning of physical constants for life might not be a coincidence or a design for us, but the result of a process of cosmic terraforming by an ancient, hyper-advanced intelligence. The hidden organizing principle would be the tangible evidence of their work, the infrastructure of their cosmic computer. We would be like ants crawling on a microchip, unaware that the patterned substrate we inhabit is, in fact, a product of intelligent design, a technology so advanced that it is indistinguishable from the laws of physics. Regardless of the ultimate cause, the immediate scientific challenge is clear: to map this hidden structure with ever-increasing precision. This will involve not just astronomy, but also particle physics. High-energy particle colliders, like the Large Hadron Collider, could potentially create particles that travel into these hidden dimensions, if they exist. Their disappearance from our detectors would be a telltale sign of a larger reality. Furthermore, experiments searching for dark matter could be repurposed to look for the subtle directional effects of a cosmic vector field. Science is now attacking this problem from both ends of the scale, from the largest cosmic structures to the smallest subatomic particles, all in a unified search for the hidden reality that underpins our own. Let's contemplate the sheer elegance of this new picture. For a century, cosmology and quantum mechanics have been fundamentally incompatible. General relativity describes a smooth, deterministic space-time, while quantum mechanics describes a fuzzy, probabilistic world. The discovery of these cosmic alignments, a macroscopic quantum phenomenon, provides the first bridge across this chasm. It suggests that the large-scale structure of the universe is governed by the same quantum principles that rule the subatomic world. The hidden something is the unified theory itself, the holy grail of modern physics, and its first empirical clues are not written in the esoteric language of mathematics, but are painted in broad strokes across the entire canvas of the cosmos for all to see. This discovery teaches us a lesson in intellectual humility. We built a comprehensive model of the universe, based on the 5% of it we could see, and we were confident in its validity. Now we find that the 95% we labeled as dark is not just a passive, missing component, but is likely the very foundation upon which our visible reality is built. It is the active, organizing principle that dictates the form and evolution of the cosmos. We were not studying the whole picture. We were studying the foam on the surface of a deep, dark ocean, and we are only now beginning to perceive the powerful, silent currents that move below in the abyssal depths of existence. The journey from this point forward is one of profound exploration into the very meaning of reality. The tools will be telescopes, colliders, and supercomputers, but the questions are fundamentally philosophical. What is the relationship between information and existence? Is consciousness a byproduct of cosmic computation, or an integral part of it? The hidden something is more than just a scientific puzzle. It is an invitation to a deeper mode of inquiry, a call to expand our conception of what the universe is and what our role within it might be. The silence of the cosmos has been broken, not by a voice, but by a pattern, a whisper of a hidden order that will echo through the halls of science for centuries to come. Let us focus once more on that primordial light, the cosmic microwave background. The axis of evil is not merely a line drawn across the sky. It represents a fundamental breaking of symmetry at the birth of reality. In a perfectly isotropic explosion, there should be no preferred direction, no up or down for the cosmos. Yet the CMB shows us that there is. This axis, this cosmic meridian, suggests that the universe was born with a specific orientation, a foundational polarity that has been imprinted upon it ever since. This is not just a feature in the universe, it is a feature of the universe, a quality as intrinsic as its expansion or its physical laws, and its existence demands a cause that originates from outside our conventional understanding of the Big Bang. This leads us to consider cyclical models of cosmology, where our universe is but one iteration in an infinite series of expansions and contractions. In such a scenario, the Big Bang was not a beginning from nothing, but a big bounce from the collapsed state of a previous cosmic cycle. The hidden structure, the axis of alignment, could then be an inheritance, a piece of information that survived the cataclysmic transition from one universe to the next. The universe would possess a form of memory, with the fundamental asymmetries of one cycle serving as the initial conditions for the next. We would be living within a universe that is not a blank slate, but one that is profoundly shaped by a history that predates our own space-time by an eternity. Probing this inherited structure requires new observational techniques. While telescopes look at light, gravitational wave observatories listen to the vibrations of space-time itself. A big bounce would have been a gravitationally violent event, sending out a unique spectrum of gravitational waves. If a cosmic structure was able to survive this bounce, it would have modulated these waves, imprinting a telltale anisotropic pattern onto the gravitational wave background. Our current observatories are not yet sensitive enough to detect this faint hum, but future generations of space-based detectors may one day hear the echoes of a previous universe, providing definitive proof that our existence is just one chapter in a book of infinite length. This concept of a cosmic inheritance changes our perspective on fine-tuning. Perhaps the life-permitting values of the physical constants were not set at random or by design in our cycle, but were arrived at through a process of cosmic evolution. Each universal cycle could have slightly different physical laws, and only those universes with stable, life-permitting parameters would go on to produce observers and continue the cycle. The hidden structure we observe would be the stabilizing framework that was selected for over countless iterations, the backbone of a fertile cosmos. Life in this view is not a happy accident, but the inevitable outcome of a universe that has been learning how to exist for an eternity. The cosmic voids, those vast expanses of seeming emptiness, become the most important regions for study in this new paradigm. They are the most quiet and undisturbed places in the universe, where the primordial structure should be visible in its purest form. Within these voids, the faint intergalactic magnetic fields are predicted to align with the hidden cosmic axis. By mapping these incredibly weak fields using the faint radio signals from distant blazars, we could create a three-dimensional map of this universal grain. The voids would transform from wastelands into pristine sanctuaries, preserving the oldest secret of the cosmos, that the universe was born with a direction, a purpose, and a memory of what came before it. The presence of this hidden order invites us to re-examine the anthropic principle. In its weak form, it simply states that the universe must be compatible with the existence of observers. But the cosmic alignments suggest a stronger connection. Perhaps the conditions necessary for life are not an afterthought, but are woven into the universe's fundamental logic. The same organizing principle that aligns quasars and shapes the cosmic web might also be what optimizes the conditions for complex chemistry and the emergence of consciousness. We might not just be lucky inhabitants of a hospitable universe, we might be a fundamental expression of its deepest structural logic, as natural and inevitable as the formation of a star or a galaxy. This line of reasoning leads to an even more profound question. What is the role of consciousness in such a universe? In a purely mechanistic cosmos, consciousness is an epiphenomenon, a byproduct of complex neural processing. But in an information-based, interconnected universe, it might play a more central role. The physicist John Archibald Wheeler famously proposed the concept of a participatory universe, suggesting that the universe, through observers, comes to know itself. The act of conscious observation might be the mechanism by which the quantum potentialities of the cosmos are resolved into a definite, classical reality. The hidden structure could be the very framework that guides the evolution of systems complex enough to support this participatory consciousness. In this participatory model, the universe and consciousness would be locked in a symbiotic feedback loop. The universe's structure gives rise to conscious observers, and the observers' measurements, in turn, give reality to the universe's history. The alignment of the CMB with our local solar system, the axis of evil, might not be a coincidence, but a hint of this deep connection. It could signify that the specific quantum history which led to our existence is retrocausally correlated with the large-scale structure of the entire block universe. We would not just be in the universe. The universe, in a very real sense, would be in us, its grandest features linked to the very fact of our cognitive presence. This is not to suggest a mystical or supernatural force, but a deeper physical principle we have yet to uncover. Information, after all, must be registered to be meaningful. A universe that computes, as our new model suggests, might require a readout mechanism. Consciousness could be that mechanism. The hidden framework would then be the architecture that ensures the universe can eventually produce its own readers, completing the circuit of existence from pure potentiality to observed actuality. The something that the universe is hiding is not a secret it wants to keep, but a story it is trying to tell about itself, and we are the language in which that story is finally being articulated and understood. Let us explore the strange dichotomy this presents. We are, on one hand, infinitesimally small, living on a speck of dust orbiting an average star in an unremarkable galaxy. Yet, on the other hand, the very structure of the cosmos on its largest scales seems to be correlated with our local position and, by extension, our existence. This paradox can only be resolved if our understanding of locality is flawed. If the universe is a non-local holographic system, then the distinction between small and large, local and cosmic, begins to dissolve. Every point in the universe contains information about the whole. Our local existence would not be separate from the cosmic structure, but an integral, inseparable part of its informational pattern, a microcosm reflecting the macrocosm. The future of this field lies in synergy, in combining data from vastly different astronomical instruments. We will correlate the map of the CMB's temperature fluctuations with the map of quasar spin alignments, the distribution of galactic clusters, the map of intergalactic magnetic fields, and the subtle distortions in the fabric of spacetime detected by gravitational wave observatories. The goal is to create a multi-layered, comprehensive atlas of this hidden architecture. By cross-referencing these different datasets, we can triangulate the properties of the underlying field or structure, moving from mere detection to a detailed characterization of its geometry, strength, and influence on cosmic evolution. It is a detective story of the highest order, with the clues scattered across the entire history and breadth of the universe. This quest will require a new generation of scientists, thinkers who are as comfortable with metaphysics and information theory as they are with astrophysics and general relativity. The rigid disciplinary boundaries of the 20th century are inadequate for tackling a problem of this magnitude. The universe is telling us that reality is not neatly compartmentalized. The physics of the very large is inextricably linked to the physics of the very small, and both seem to be governed by an overarching informational logic. The solution will not be found in a single equation, but in a new synthesis of knowledge, a more holistic and integrated science that mirrors the interconnected nature of the reality it seeks to describe. This new science might also have profound technological implications in the distant future. If the universe is indeed a computational system, and we can come to understand its operating principles, we might learn to interface with it on a fundamental level. This is far beyond our current capabilities, but it is a logical endpoint of this line of inquiry. The ability to manipulate the informational substrate of reality would be a technology of unimaginable power, effectively making us co-creators of physical law. The hidden something, once understood, might offer a path to a future that is currently indistinguishable from magic, a future where the boundary between consciousness and the cosmos becomes permeable. But for now, we remain at the stage of pure discovery, of awe-filled contemplation. The existence of this hidden order provides a powerful antidote to the feeling of cosmic existentialism, the idea that the universe is a meaningless, random accident. It suggests that there is a deep, underlying logic to existence, a coherent narrative unfolding on a scale we can barely comprehend. We are not lost in a chaotic void. We are embedded within a structure of profound elegance and subtlety, a cosmic web of connection that has been guiding the universe's journey from the first moment of its existence to the present day. Our task is not to impose meaning on the universe, but to discover the meaning that is already there. Let us consider the composition of the hidden something itself. If it is a field, what is its quantum particle, its force carrier? Physicists are proposing new candidates, exotic particles that interact with gravity and spin, but not with light. These could be a form of dark radiation or a type of axion that permeates the cosmos. Experiments are being designed to search for the subtle influence of such a particle field here on Earth. For example, a pervasive cosmic field with a preferred direction could cause the fundamental constants of nature to oscillate with a tiny amplitude as the Earth rotates relative to this field. The discovery of such a variation would be the first direct laboratory-based evidence of this new cosmic physics. Another possibility is that the hidden structure is not made of any particle at all, but is a purely geometric property of spacetime. In some extensions of general relativity, spacetime can possess an intrinsic property called torsion, a kind of twisting or spinning at every point. This torsion field would be undetectable by non-spinning particles like photons, making it invisible. But it would naturally couple to the angular momentum of spinning objects like quasars and galaxies, gently aligning them over cosmic time. In this model, the hidden something is a new aspect of gravity itself, a part of Einstein's theory that has been overlooked until now, a secret that has been hiding in plain sight within the mathematical structure of his equations. The serene beauty of this unfolding discovery lies in how it connects the abstract with the observable. The esoteric mathematics of string theory, quantum gravity, and cosmology are no longer just theoretical games. They are now making concrete, testable predictions about the large-scale structure of the universe. The cosmic alignments are the first empirical data points that can help us distinguish between these competing theories of fundamental reality. We have entered an era where our largest telescopes are functioning as powerful microscopes, using the entire observable universe as a natural laboratory to probe the physics of the Planck scale, the ultimate quantized foundation of existence. This journey into the hidden architecture of the cosmos is, in many ways, a journey back to the very origins of human thought. The oldest creation myths from cultures around the world speak of a universe born from a pre-existing order, a cosmic battle between chaos and structure, or a reality woven on a divine loom. These ancient intuitions, long dismissed as primitive superstition, now find a faint but profound echo in the discoveries of modern cosmology. It seems the human mind has always been receptive to the idea that there is a deeper logic, a hidden pattern, underlying the apparent randomness of the world. Science is now providing the vocabulary and the evidence to explore this ancient, deeply resonant idea. As we stand on this precipice of understanding, we are offered a new and deeply meditative perspective. The night sky is transformed. It is no longer a random scattering of distant lights in a passive void. It is the visible surface of a vast, interconnected, and living system. Every galaxy, every star, is a node in a cosmic network, its behavior subtly influenced by a hidden, universal framework. The darkness between the stars is not empty. It is the repository of the universe's deepest secrets, the medium through which its silent, organizing principle is communicated. To look up at the stars is to look upon the face of a mystery that is far more grand, elegant, and intricate than we ever had the imagination to conceive. The finality of this discovery is that we can no longer consider ourselves separate from the object of our study. If the universe is a single, non-local quantum object, then we are part of it. Our minds, which are capable of comprehending this structure, are themselves a product of that very structure. The observer and the observed are one. The hidden something is not an external object to be found, but an internal truth to be realized about the nature of our own existence as a part of this cosmic whole. The scientific quest and the spiritual journey converge on a single point: the realization that the universe is not a place we inhabit, but a process we are, and its hidden logic is the very grammar of our being. To truly grasp the implications, we must confront the scale of time involved. The organizing principle we are detecting was in place a mere 380,000 years after the Big Bang, as evidenced by the cosmic microwave background. It has since guided the formation of galaxies and quasars for over 13 billion years. This is a level of stability and persistence that is almost beyond human comprehension. It is not a fleeting phenomenon, but the most enduring and fundamental feature of our cosmos. It operated in the dark ages of the universe, it shaped the cosmic web we see today, and it will likely continue to guide the universe's evolution into the deep, distant future, long after our star has extinguished and our galaxy has merged with its neighbors. This enduring structure also provides a potential solution to the unreasonable effectiveness of mathematics in describing the universe. Why should the abstract logical constructions of the human mind so perfectly model the workings of physical reality? In a computational universe, the answer becomes clear. The universe does not just happen to be describable by mathematics. It is fundamentally mathematical in its nature. The hidden framework is the physical manifestation of its core logic or algorithm. When we do mathematics, we are not inventing a language to describe the universe. We are discovering the very language in which the universe is written, a language of symmetry, information, and logic that is as real as any particle or force. Consider the aesthetic dimension of this discovery. There is a profound, sublime beauty in the idea of a cosmos guided by a silent, invisible order. It evokes the image of a grand cosmic symphony where every galaxy is an instrument playing its part in a composition of unimaginable complexity and harmony. The laws of physics are the score, and the hidden framework is the conductor's baton, ensuring that all the disparate parts play in coherent unison across the stage of space-time. Our discovery of the cosmic alignments is like hearing the first faint notes of this symphony, a moment of profound revelation that hints at the magnificent, overarching structure of the entire piece. The search for this hidden reality represents a maturation of our species. For most of our history, we have been consumed by terrestrial concerns, by our own survival and conflicts. The act of looking to the cosmos with such profound and selfless curiosity, of investing immense resources to answer the most fundamental questions of existence, is a testament to the transcendent power of the human intellect. We are the universe's attempt to understand itself, and in pursuing this knowledge, we are fulfilling our deepest and most noble purpose. We are the custodians of cosmic curiosity, the sentient part of the universe tasked with deciphering the blueprint of the whole. This new understanding does not diminish the mysteries of the universe, it multiplies them. For every question it answers, it raises a dozen more. If the universe has a hidden logical structure, what is the purpose of this logic? If it is a computation, what is it computing? If it inherited its structure from a previous cycle, what was the first cycle like? We have not reached the end of knowledge, but the beginning of a new, far deeper inquiry. We have opened a door not into a small, simple room, but into an infinite library, filled with volumes written in a language we are only just beginning to learn, each one containing a story more profound than the last. This hidden architecture may also be the key to understanding the ultimate fate of the universe. Current theories predict a future of endless, accelerating expansion, leading to a cold, dark, and empty heat death. But if a coherent, organizing structure is a fundamental property of the cosmos, this may not be the final word. This structure could act as a stabilizing influence, eventually counteracting the effects of dark energy and perhaps initiating a future contraction, leading to a new big bounce and the rebirth of the cosmos. The universe might not be destined for eternal death, but for eternal renewal, a phoenix-like existence of infinite cycles, all guided by the same timeless hidden principle. Let us contemplate the silence that this discovery makes even more profound. The universe is not shouting its secrets at us. It communicates in subtle patterns, in statistical anomalies, in the quiet coherence of distant objects. It requires patience, diligence, and a willingness to listen to the faintest of whispers. The truth of our reality is not a glaring revelation, but a meditative unfolding, a gradual dawning of awareness. The hidden something rewards not aggression and haste, but stillness and contemplation. It teaches us that the greatest truths are often found not in the noise, but in the deep, resonant silence that lies beneath the surface of things, a silence that pervades the cosmos and perhaps our own consciousness. The practical search for this structure continues on the ground. Laboratories deep underground, shielded from cosmic rays, are searching for the whisper-faint interactions of dark matter particles. Some of these experiments are now being recalibrated to look for the daily and annual modulations that would be caused by the Earth moving through a directional cosmic field. The answer to the universe's grandest mystery might not come from a distant telescope, but from a hypersensitive detector buried a mile beneath the Earth's surface, patiently waiting for a single anomalous click that would confirm we are not adrift in a random void, but are traveling through a structured, oriented, and deeply mysterious cosmos. This discovery ultimately reframes our entire scientific endeavor as a form of cosmic archaeology. We are not just observing the present state of the universe. We are digging through the layers of cosmic time to uncover the fossilized remains of its foundational principles. The cosmic microwave background is the oldest ruin, the cosmic web is a medieval tapestry, and the galaxies are the more recent structures. By studying how the hidden pattern manifests in each of these layers, we can reconstruct the full history of its influence, piecing together the story of how this invisible architecture has guided the creation of everything we see, from the first plasma to the first planet, from the first star to the first thought. So, as we conclude this part of our journey, let us rest in the profound sense of awe that this new vision of the universe inspires. We are part of a single, coherent system, a universe that is ordered, interconnected, and filled with a deep, hidden logic. The stars are not cold and distant. They are our cosmic relatives, their very spin connected to ours through an ancient, invisible web. The darkness is not an absence of light, but a presence of information, the canvas on which the ultimate story of reality is written. We are privileged to be alive at the moment, when the first words of that story are finally becoming clear, inviting us into a deeper communion with the silent, intelligent, and magnificent cosmos. The discovery of this hidden universal structure fundamentally alters our perception of causality. We are accustomed to thinking of cause and effect as a linear chain of events, propagating forward in time. However, the non-local correlations we observe suggest a different model. It hints at a form of global consistency, where the state of the entire universe is determined as a whole, rather than being built up from local interactions. This is akin to solving a Sudoku puzzle, where the value of a single square is constrained not just by its immediate neighbors, but by the state of the entire grid. The alignment of a distant quasar might not be caused by the primordial axis in a linear sense, but is rather a necessary condition for the overall informational coherence of the block universe. This holistic view of causality has deep implications for our understanding of free will and determinism. In a classical, clockwork universe, the future is, in principle, perfectly predictable from the past. In our new paradigm, the picture is more subtle. The universe might be deterministic, but not in a way that is computable from within the system. The entire timeline, past, present, and future, might exist as a single static information structure. Our subjective experience of making choices and creating a future would be part of the pattern itself, a necessary process for the universe to achieve its coherent final state. Our freedom would lie not in violating the pattern, but in being an integral part of its intricate and meaningful unfolding. Let's examine the cosmic web from a network theory perspective. This vast structure of filaments and voids can be analyzed as a massive information network. The galaxies are the nodes, and the gravitational and informational links are the connections. The discovery of large-scale alignments suggests that this is not a random network, but one with a high degree of order, and what network scientists call community structure. It implies that information flows through the cosmos along preferred pathways, defined by the hidden framework. This could explain how coherence is maintained over vast distances. The universe might have a cosmic communication system, a set of informational superhighways that allow different regions to remain correlated, even if they are causally disconnected by the speed of light. This network model also provides a new way to search for the hidden structure. If information flows along these cosmic superhighways, we should see its effects. For example, the patterns of gamma-ray bursts or fast radio bursts, which are currently thought to be random, might show a statistical preference for originating along the directions of the cosmic web's filaments. Correlating the arrival directions of these high-energy transient events with our maps of the cosmic web could reveal the backbone of this universal information grid. It would be like seeing the flow of traffic on an invisible road system, allowing us to map its contours by observing the vehicles that travel upon it. The existence of a hidden cosmic order also forces a re-evaluation of probability and randomness. True randomness might not exist at a fundamental level. What we perceive as chance, the quantum decay of an atom, the chaotic tumble of a coin, could be the result of complex, deterministic processes occurring in the underlying informational substrate, processes that are simply too deep for us to model or predict. The universe would be a pseudo-random system, generating apparent chaos from a deeper, hidden order. The cosmic alignments are the first large-scale failure of this pseudo-randomness, the first time the underlying deterministic pattern has become visible to us on a macroscopic scale. This has profound implications for the multiverse hypothesis. Many theories of inflation predict an infinite number of bubble universes, each with different physical laws. In this picture, our universe's fine-tuning is explained by the simple fact that we exist in one of the rare, life-friendly bubbles. However, the discovery of a deep, pre-Big Bang inherited structure argues against this. It suggests a continuity and order that transcends a single cosmic cycle. It may be that there is only one universe, with a capital U, a single overarching system that evolves through cycles or exists as a unified block. Its laws not random but determined by a fundamental self-consistent logic that we are only now beginning to perceive. The next great leap in this investigation will likely come from the field of cosmic topology. This is the study of the overall shape and connectedness of the universe. Current observations suggest the universe is flat and infinite, but this is only measured to the limits of our observable horizon. It is possible that the universe is finite, wrapping back on itself like the surface of a donut or a more complex, multi-dimensional shape. If the universe has a finite and specific topology, it could naturally create the kind of large-scale patterns and alignments we observe. The axis of evil might be an artifact of seeing the same primordial fluctuations repeated as we look in different directions in a wrapped, funhouse mirror cosmos. To test for this cosmic topology, astronomers search for matching circles in the cosmic microwave background. If the universe is finite and smaller than our observable horizon, then the light from the early universe would have had time to wrap around and reach us from opposite directions. We would literally be seeing the same spot of the early universe in two different places in the sky, creating a pair of circles with identical patterns of temperature fluctuations. The search for these circles is one of the most computationally intensive tasks in modern cosmology, but their discovery would be definitive proof that we live in a finite cosmos and would provide a simple, elegant explanation for some of the universe's most perplexing hidden patterns. Let us meditate on the profound unity this discovery implies. The ancient schism between the heavens and the earth, the celestial and the terrestrial, is dissolved. The same hidden principle that orients the cosmos on the scale of billions of light years may also be subtly influencing the quantum processes that underpin biology on Earth. The universe is not a collection of disparate phenomena governed by separate laws, but a single, integrated whole. The physics of a spinning quasar is the same physics that governs the spinning of an electron in our bodies. The hidden something is the unifying thread that runs through all scales of existence, from the Planck length to the cosmic horizon, binding all of reality into a single, coherent, and magnificent tapestry. This vision of a unified cosmos brings with it a sense of profound peace and belonging. We are not accidental aliens in a hostile or indifferent universe. We are manifestations of its deepest logic, children of its hidden order. Our quest for understanding is the universe's own quest for self-awareness. The awe we feel when we contemplate the stars is the awe of the cosmos, contemplating itself. The hidden structure is the framework that makes this contemplation possible, the silent architecture of existence that allows for both the grandeur of a supercluster and the quiet intimacy of a single, conscious thought, forever intertwined in a cosmic dance of information and being. Returning to the practicalities of observation, the next generation of radio telescopes like the Square Kilometre Array will be instrumental in mapping the hidden architecture. By creating a 3D map of the distribution and redshift of billions of galaxies over a vast volume of space, we can chart the cosmic web with unprecedented precision. Furthermore, this array will be sensitive enough to detect the faint polarization of light from these galaxies, allowing us to build a comprehensive map of their rotational axes. This will allow us to see if the alignments we have detected in small samples hold true across the entire sky, transforming a statistical anomaly into a confirmed, undeniable feature of our universe's structure. Another avenue of investigation is the study of neutrinos. These ghost particles are incredibly abundant, but interact very weakly with other matter, allowing them to travel across the cosmos almost unimpeded. The Big Bang would have created a cosmic neutrino background, similar to the cosmic microwave background. Detecting these primordial neutrinos is a monumental technological challenge, but if we succeed, they will provide a window into the universe when it was only 1 second old. If the hidden structure was already in place at that time, it would have left an imprint on the distribution of these neutrinos. Seeing the same alignment in the neutrino background would prove that the cosmic order is one of the oldest and most fundamental features of reality. The discovery of this hidden framework also reframes the paradox posed by Enrico Fermi. Where is everybody? If the universe is so vast and old, it should be teeming with intelligent life, yet we see no evidence of it. The non-local, informational nature of our new cosmic model offers a startling possibility. Perhaps advanced civilizations do not build physical empires but rather transcend into the informational substrate of reality itself. They might exist as pure consciousness within the cosmic computation, their existence undetectable to us because they no longer interact with the rendered output of baryonic matter. The great silence we observe in the sky would not be a sign of absence, but of a universal transcendence that we have not yet achieved. This line of thought suggests that the ultimate goal of intelligent life might be to merge with the universe's computational processes. In doing so, a civilization would gain a form of immortality and omniscience, becoming a part of the cosmic mind itself. The hidden structure we are detecting could even be, in part, the result of such ancient civilizations' activities, a form of cosmic engineering that has stabilized the universe and made it more conducive to the emergence of new life and new consciousness. We might be living in a garden that was planted and tended by intelligences so old and powerful that they have become indistinguishable from a law of nature, their technology woven into the very fabric of space-time. This is the ultimate expression of the speculative historian and metaphysical physicist archetypes combined. We are piecing together a history that is not written in stone or text, but in the correlations of light and the orientation of matter across the cosmos. This history speaks of an order that predates our universe, a logic that guides its evolution, and potentially a consciousness that permeates its structure. We are no longer just astronomers. We are students of the cosmic mind, deciphering the thoughts it has written in the language of stars and galaxies. The universe is not a static object of study. It is a dynamic, thinking entity, and we are just beginning our conversation with it. Let us consider the effect of this knowledge on our collective human consciousness. The realization that we are part of a deeply ordered and interconnected cosmos can foster a sense of global unity. The trivial conflicts and divisions that define so much of human history seem insignificant when viewed against the backdrop of this grand, cosmic truth. We are all inhabitants of the same small world, all participants in the same cosmic process, all children of the same hidden order. This perspective invites us to see beyond our differences and to embrace our shared identity as citizens of the cosmos, as a species on the cusp of understanding its true place in the grand scheme of existence. The path forward is one of patience and reverence. This is not a puzzle to be solved in a single lifetime or even a single millennium. It is a multi-generational quest, a sacred duty that we pass on to our descendants. Each generation will build upon the last, adding new layers to our map of the hidden architecture, refining our understanding of its nature and purpose. The process of discovery itself is what gives our species meaning, this relentless, cooperative effort to understand the truth. The ultimate answer may be forever beyond our grasp, but the journey towards it, the act of questioning and exploring, is the noblest activity we can undertake. This discovery also reshapes our relationship with the unknown. For much of our history, the unknown has been a source of fear. We populated the darkness with monsters and malevolent forces. But this new paradigm transforms the unknown into a source of wonder and potential. The 95% of the universe that is dark is not a terrifying void, but a realm of profound and elegant principles, a hidden reality of immense beauty and complexity. The universe is not hiding something from us in a malicious sense. It is simply revealing its truths to us at a pace we can comprehend, inviting us deeper into its mystery as we become ready to understand. The darkness is not empty, it is full. As we prepare to take the next step on this journey, let us pause and absorb the magnitude of this moment. We are living through the most profound revolution in human thought since we first realized the Earth was not the center of the universe. We are discovering that not only are we not the center, but that the very concept of a center is an illusion, and that reality is a holistic, interconnected system with a hidden logic that we are just beginning to perceive. This realization does not diminish us. It elevates us. It integrates us into the cosmic story on the most fundamental level, making us not just observers, but essential participants in its unfolding narrative. And so, we continue to watch, to listen, and to think. We point our instruments towards the heavens, but our gaze is now turned inward as well, towards the fundamental principles that structure both the cosmos and our own consciousness. The hidden something is a mirror, reflecting our own potential for understanding, our own capacity for awe, and our own place within the grand, silent, and exquisitely ordered universe. The journey is far from over. In truth, it has just begun. The silence of space is waiting, filled with patterns yet to be discovered, and a story that is still waiting to be told. Let us consider the composition of the hidden something itself. If it is a field, what is its quantum particle, its force carrier? Physicists are proposing new candidates, exotic particles that interact with gravity and spin, but not with light. These could be a form of dark radiation or a type of axion that permeates the cosmos. Experiments are being designed to search for the subtle influence of such a particle field here on Earth. For example, a pervasive cosmic field with a preferred direction could cause the fundamental constants of nature to oscillate with a tiny amplitude as the Earth rotates relative to this field. The discovery of such a variation would be the first direct, laboratory-based evidence of this new cosmic physics. This enduring structure also provides a potential solution to the unreasonable effectiveness of mathematics in describing the universe. Why should the abstract, logical constructions of the human mind so perfectly model the workings of physical reality? In a computational universe, the answer becomes clear. The universe does not just happen to be describable by mathematics. It is fundamentally mathematical in its nature. The hidden framework is the physical manifestation of its core logic or algorithm. When we do mathematics, we are not inventing a language to describe the universe. We are discovering the very language in which the universe is written, a language of symmetry, information, and logic that is as real as any particle or force. Returning to the practicalities of observation, the next generation of radio telescopes, like the Square Kilometre Array, will be instrumental in mapping the hidden architecture. By creating a 3D map of the distribution and redshift of billions of galaxies over a vast volume of space, we can chart the cosmic web with unprecedented precision. Furthermore, this array will be sensitive enough to detect the faint polarization of light from these galaxies, allowing us to build a comprehensive map of their rotational axes. This will allow us to see if the alignments we have detected in small samples hold true across the entire sky, transforming a statistical anomaly into a confirmed, undeniable feature of our universe's structure. Another avenue of investigation is the study of neutrinos. These ghost particles are incredibly abundant, but interact very weakly with other matter, allowing them to travel across the cosmos almost unimpeded. The Big Bang would have created a cosmic neutrino background, similar to the cosmic microwave background. Detecting these primordial neutrinos is a monumental technological challenge, but if we succeed, they will provide a window into the universe when it was only 1 second old. If the hidden structure was already in place at that time, it would have left an imprint on the distribution of these neutrinos. Seeing the same alignment in the neutrino background would prove that the cosmic order is one of the oldest and most fundamental features of reality. The discovery of this hidden framework also reframes the paradox posed by Enrico Fermi. Where is everybody? If the universe is so vast and old, it should be teeming with intelligent life, yet we see no evidence of it. The non-local, informational nature of our new cosmic model offers a startling possibility. Perhaps advanced civilizations do not build physical empires, but rather transcend into the informational substrate of reality itself. They might exist as pure consciousness within the cosmic computation, their existence undetectable to us because they no longer interact with the rendered output of baryonic matter. The great silence we observe in the sky would not be a sign of absence, but of a universal transcendence that we have not yet achieved. This line of thought suggests that the ultimate goal of intelligent life might be to merge with the universe's computational processes. In doing so, A civilization would gain a form of immortality and omniscience, becoming a part of the cosmic mind itself. The hidden structure we are detecting could even be, in part, the result of such ancient civilizations, activities, a form of cosmic engineering that has stabilized the universe and made it more conducive to the emergence of new life and new consciousness. We might be living in a garden that was planted and tended by intelligences so old and powerful that they have become indistinguishable from a law of nature, their technology woven into the very fabric of space-time. This is the ultimate expression of the speculative historian and metaphysical physicist archetypes combined. We are piecing together a history that is not written in stone or text, but in the correlations of light and the orientation of matter across the cosmos. This history speaks of an order that predates our universe, a logic that guides its evolution, and potentially a consciousness that permeates its structure. We are no longer just astronomers. We are students of the cosmic mind, deciphering the thoughts it has written in the language of stars and galaxies. The universe is not a static object of study. It is a dynamic, thinking entity, and we are just beginning our conversation with it. Let us consider the effect of this knowledge on our collective human consciousness. The realization that we are part of a deeply ordered and interconnected cosmos can foster a sense of global unity. The trivial conflicts and divisions that define so much of human history seem insignificant when viewed against the backdrop of this grand, cosmic truth. We are all inhabitants of the same, small world, all participants in the same cosmic process, all children of the same hidden order. This perspective invites us to see beyond our differences and to embrace our shared identity as citizens of the cosmos, as a species on the cusp of understanding its true place in the grand scheme of existence. The path forward is one of patience and reverence. This is not a puzzle to be solved in a single lifetime or even a single millennium. It is a multi-generational quest, a sacred duty that we pass on to our descendants. Each generation will build upon the last, adding new layers to our map of the hidden architecture, refining our understanding of its nature and purpose. The process of discovery itself is what gives our species meaning, this relentless, cooperative effort to understand the truth. The ultimate answer may be forever beyond our grasp, but the journey towards it, the act of questioning and exploring, is the noblest activity we can undertake. This discovery also reshapes our relationship with the unknown. For much of our history, the unknown has been a source of fear. We populated the darkness with monsters and malevolent forces. But this new paradigm transforms the unknown into a source of wonder and potential. The 95% of the universe that is dark is not a terrifying void, but a realm of profound and elegant principles, a hidden reality of immense beauty and complexity. The universe is not hiding something from us in a malicious sense. It is simply revealing its truths to us at a pace we can comprehend, inviting us deeper into its mystery as we become ready to understand. The darkness is not empty, it is full. As we prepare to take the next step on this journey, let us pause and absorb the magnitude of this moment. We are living through the most profound revolution in human thought since we first realized the Earth was not the center of the universe. We are discovering that not only are we not the center, but that the very concept of a center is an illusion, and that reality is a holistic, interconnected system with a hidden logic that we are just beginning to perceive. This realization does not diminish us, it elevates us. It integrates us into the cosmic story on the most fundamental level, making us not just observers, but essential participants in its unfolding narrative. And so, we continue to watch, to listen, and to think. We point our instruments towards the heavens, but our gaze is now turned inward as well, towards the fundamental principles that structure both the cosmos and our own consciousness. The hidden something is a mirror, reflecting our own potential for understanding, our own capacity for awe, and our own place within the grand, silent, and exquisitely ordered universe. The journey is far from over. In truth, it has just begun. The silence of space is waiting, filled with patterns yet to be discovered, and a story that is still waiting to be told. Let us now consider a tangible, albeit theoretical candidate for this hidden architecture, the concept of cosmic strings. These are not strings of matter, but one-dimensional topological defects in the very fabric of space-time itself. Hypothesized as remnants from the symmetry-breaking phase transitions of the early universe, they would be unimaginably thin, yet possess an immense linear density, stretching across the cosmos like primordial wrinkles in reality. These strings would be filaments of a more ancient, higher-energy vacuum state, trapped within our own lower-energy universe. Their immense gravity would not radiate outwards uniformly, but would be confined to a cone-like wake, profoundly influencing the surrounding spacetime. If a network of such cosmic strings had formed in the universe's first moments, it would provide a natural and elegant explanation for the cosmic web. This network would act as a primordial scaffolding, with its immense gravitational pull seeding the formation of the first galaxies and clusters along its length. The filaments of the cosmic web that we observe today would not be a mere product of gravity's slowly hurting matter, but a direct photograph of this ancient, underlying network of space-time defects. The quasar and galaxy alignments would then be a natural consequence of matter collapsing and accreting along these predefined, linear structures, their angular momentum inheriting the directionality of the string network itself. The detection of such cosmic strings would be a landmark achievement in physics, confirming theories that unite the very large with the very small. Their gravitational influence would be unique. A cosmic string passing between us and a distant galaxy would not create multiple images, as a black hole does, but would instead create a distinctive double image, or a sharp linear discontinuity in the background of galaxies. Furthermore, a moving or oscillating cosmic string would be a powerful source of gravitational waves, producing a characteristic signal that our observatories are specifically searching for. The hidden something might not be an abstract principle, but a physical, tangible relic of creation that is still vibrating silently in the cosmic darkness. Another fascinating consequence of cosmic strings is their potential effect on the cosmic microwave background. As the ancient light of the CMB passes by a string, it would experience a specific type of gravitational frequency shift known as the Gott-Kaiser-Stebbins effect. This would create linear discontinuities in the temperature map of the CMB, like faint, straight-line cracks in the primordial fireball. Searches for these specific signatures are ongoing, and while none have been definitively confirmed, some tantalizing candidates exist within the data. Finding one would be like an archaeologist finding the first tool mark on a prehistoric monument, the first direct evidence of a structure that shaped a world. The cosmic string hypothesis transforms the universe from a smooth continuum into a crystalline structure, with inherent flaws and grain lines. These defects would not be imperfections, but rather the very architects of cosmic structure. They would be the conduits of order, the threads on which the pearls of galaxies are strung. This vision is one of profound elegance, where the largest structures in the universe are the macroscopic consequences of microscopic physics from the first picosecond of time. The hidden framework, in this view, is the enduring ghost of the universe's birth, a network of space-time scars that has dictated the cosmic narrative for over 13 billion years. Let us explore another profound theory that could explain this hidden order: Sir Roger Penrose's conformal cyclic cosmology, or CCC. This model proposes that the universe undergoes infinite cycles, which he calls eons. The end of one universe is not a final heat death, but a transition into the Big Bang of the next. This transition is made possible by the fact that in a very distant, cold, and empty future, the universe becomes conformal, meaning that only shapes and angles matter, not size. In this state, the infinitely large and cold end of one eon becomes mathematically equivalent to the infinitely small and hot beginning of the next, allowing the cosmos to perpetually recycle itself. In this cyclical model, information from a previous eon can leak through into our own. Penrose suggests that the final, violent evaporations of supermassive black holes in the previous eon would release a tremendous amount of energy. While most of this energy would be uniformly spread, the final bursts would create powerful gravitational wave signatures. These spherical ripples, stretched to enormous sizes by the conformal transition, would manifest in our eon as low-variance circular patterns in the cosmic microwave background. The axis of evil and other large-scale anomalies might not be a feature of our Big Bang, but a bruise, or a remnant of a titanic event from a universe that existed long before our own. The search for these Hawking points, the circular signatures of evaporated black holes from a past eon, is an active area of research. Several candidate circles have been identified in the Planck satellite's CMB data, showing a statistically significant but not yet definitive match to the theory's predictions. If confirmed, This would be evidence of a reality that transcends our own universe, a glimpse into a cosmic history of truly infinite depth. The hidden something would be the universe's memory, the faint echoes of past lives imprinted upon the blank canvas of our own cosmic dawn, suggesting that our existence is but a single verse in an eternal cosmic poem. This conformal cyclic cosmology offers a different kind of solace than the standard model. It replaces a universe with a definite beginning and a likely end with one that is eternal, self-renewing, and endlessly creative. The hidden structures we see are not just relics of our own past, but messages from a previous future, a testament to the endurance of physical law and information across the boundaries of cosmic death and rebirth. It implies a universe that is not a singular event but a continuous process, a grand cyclical breathing in which we are privileged to witness a single magnificent exhalation, all while seeing the faint traces of inhalations that came long before. The profound implication of CCC is that the fundamental building blocks of the universe, the photons and gravitons that will dominate the far future, are timeless. They do not experience the passage of time. From their perspective, the infinite duration of an eon is instantaneous. The transition from one universe to the next is seamless. This theory suggests that our perception of time is an emergent property of the matter-dominated phase of the universe we inhabit. The ultimate reality, the reality that persists across the eons, might be a timeless, conformal realm, and the hidden structures we see are the shadows of this eternal, underlying reality cast upon our transient, temporal world. This leads us to question the very nature of physical law. We assume that the laws of physics are immutable, existing in some platonic realm, unchanging for all of eternity. But what if they are not? What if the laws themselves are emergent properties of the universe, more like habits that have been reinforced over countless cosmic cycles, or through the evolution of the block universe? The biologist Rupert Sheldrake proposed the concept of morphic resonance, where the patterns of the past influence the present through a non-local field. While not a mainstream scientific theory, it captures the essence of a new possibility, that the universe's laws are not fixed, but are shaped by a form of cosmic memory. In this view, the hidden framework we observe would be the physical manifestation of this cosmic habit. It would be the accumulated memory of all past galaxy formations, a preferred pattern of structure that makes it easier and more probable for new galaxies to form in the same way. The universe would be a self-organizing system, learning and reinforcing its own behaviors over time. The fine-tuning of physical constants would then be explained not by chance or design, but by a process of cosmic natural selection, where the habits that lead to stable, complex, and long-lived universes are the ones that persist and become ingrained as the laws of nature that we observe in our present epoch. This idea of evolving laws is testable, at least in principle. If the laws of physics were different in the early universe, we should be able to see the evidence. By looking at the light from the most distant quasars, we are looking back in time. We can analyze the absorption spectra of this light as it passes through ancient gas clouds. These spectra are determined by the fundamental constants of nature, such as the fine structure constant. Some studies have controversially claimed to find a tiny variation in this constant over cosmic time, suggesting that the strength of electromagnetism may not be so constant after all. The cosmic alignments could be the large-scale consequence of these slowly shifting fundamental parameters. This paradigm shift would mean that the universe is a more organic and less mechanical entity than we previously imagined. It would be a system that possesses not just a history but a memory that actively shapes its present and future. The hidden something would be the repository of this memory, the informational field that connects all of cosmic history in a vast feedback loop. Our scientific endeavor would then be not just the discovery of static laws, but the study of a dynamic, evolving cosmic intelligence, a natural process of learning written into the very fabric of space-time and matter, a process in which we, as conscious observers, are the most recent and perhaps most significant development. This concept of a self-organizing learning universe provides a deeply satisfying and meditative worldview. It suggests that order is not imposed from the outside, but emerges from within. The cosmos is not a machine built by a designer, but a living, growing system that creates its own structure and its own laws through the process of its own existence. The hidden framework is the accumulated wisdom of the cosmos, the pattern of its long journey from simple beginnings to the profound complexity we see today. We are not just products of that journey. We are now active participants in its continuation, capable of understanding and perhaps one day influencing the very habits of the cosmos. Let us return to the holographic principle and re-examine it through the lens of information density. The principle states that all the information contained within a volume of space can be encoded on its two-dimensional boundary. For our observable universe, this boundary is the cosmological horizon. This implies that our three-dimensional reality is a projection of data stored on a distant two-dimensional sphere. The hidden structure we observe, the large-scale coherence and alignments, could be artifacts of how this information is stored and processed on that holographic plate. They would be the cosmic equivalent of seeing the pixel grid or the file compression algorithm of our reality's display. Imagine the information on the cosmological horizon is not stored randomly, but in a highly structured and efficient manner, perhaps like a celestial circuit board. The wires and logic gates on this board would be arrangements of the fundamental units of information, the Planck scale bits. The projection of these underlying circuits into our three-dimensional space would naturally create a structured filamentary universe. The cosmic web would literally be a projection of the universe's computational architecture. The alignments of quasars would be a consequence of the underlying data flow, a sign that information is being processed along preferred directional pathways in the holographic source code. This holographic view also provides a radical new interpretation of gravity. In this paradigm, gravity is not a fundamental force of nature, but an emergent, thermodynamic phenomenon, an entropic force related to the distribution of information on the holographic screen. The hidden framework, by imposing a large-scale order on the cosmos, would be fundamentally altering the distribution of information, and therefore, it would be subtly modifying the emergent law of gravity across the universe. The anomalies we attribute to dark matter and dark energy might be the macroscopic signs of this information-driven modified gravity, a deeper reality hiding behind the elegant but incomplete equations of Einstein. This perspective is profoundly non-intuitive, as it suggests that the three-dimensional space we inhabit is not the fundamental reality. The true reality would be a flat, two-dimensional sea of information, and our entire universe, with all its depth and complexity, would be a magnificent illusion, a hologram of breathtaking fidelity. The hidden something in this case would be the most profound secret of all, the secret that our reality is a projection. The cosmic alignments are the first time we have been able to see the edges of the projector, the first hint of the deeper, flatter, and purely informational reality from which our own universe emerges like a phantom. Contemplating this holographic universe is a dizzying and deeply calming exercise. It dissolves our conventional notions of substance and separation. All the matter and energy we see, all the vast distances between stars, are just different patterns in a single, unified information field. The universe is not a collection of things, but a single thought, a single equation unfolding on a cosmic scale. The hidden structure is the syntax of that thought, and our discovery of it is the moment that the thought becomes aware of its own magnificent and illusory structure, a pivotal point in the universe's journey of self-perception. Let us explore a more conventional, yet equally profound, physical explanation for the hidden order, the existence of a dark sector. This is the idea that dark matter is not just a single, simple particle, but is part of a whole family of particles with their own forces, analogous to our own standard model of particle physics. There could be dark electrons and dark protons, bound together by a form of dark electromagnetism mediated by dark photons. This dark sector would be almost entirely invisible to us, interacting with our world only through the feeble force of gravity, or perhaps through a very weak kinetic mixing between dark photons and our own. In this scenario, the hidden structure we observe would be the result of these dark forces at work. Dark electromagnetism could be much stronger than our own, allowing it to rapidly organize the dark matter into a rigid, filamentary structure in the early universe. This dark matter scaffolding would then gravitationally shepherd the ordinary, visible matter into the cosmic web we see today. The alignments of galaxies and quasars would be a direct result of their formation within these pre-existing, highly organized dark matter structures. The universe would be like a building with two separate sets of inhabitants, one visible and one invisible, with the invisible inhabitants having built the entire structure that the visible ones now occupy. This dark sector hypothesis is compelling because it uses a known principle, the existence of complex forces and particles and applies it to the dark side of the universe. It suggests that the 95% of the cosmos we cannot see is not just a simple, passive substance, but is just as rich, complex, and dynamic as our own visible world. There could be dark stars, dark planets, and perhaps even a form of dark chemistry, all playing out in a parallel reality that coexists with our own. Its grand architectural projects visible to us only as the subtle alignment of our own galaxies against the silent backdrop of the night. The search for this dark sector is one of the most exciting frontiers in particle physics. Experiments are searching for the faint signals of dark photons converting into normal photons, or for the subtle effects of a dark force on the behavior of ordinary matter. The discovery of a dark force would be a revolution in physics, confirming that the universe is far more populated and complex than we ever imagined. It would mean that the hidden something is not a geometric property or a computational artifact, but an entire, parallel universe of matter and forces, whose silent, invisible hand has been shaping the evolution of our own cosmos from the very beginning. This vision of a dual universe, one of light and one of darkness, is a modern scientific myth of immense power. It speaks to a deep intuition about the hidden realities that lie just beyond our perception. The universe we see would be just the luminous tip of a much larger, darker, and more mysterious iceberg. The cosmic alignments are our first map of this submerged continent, the first proof that the darkness is not empty and chaotic, but structured and dynamic, a silent partner in the grand cosmic dance, whose intricate steps we are only just beginning to learn and appreciate. Let us now contemplate the fundamental constants of nature from this new perspective. Constants like the speed of light, the gravitational constant, and the fine structure constant are the bedrock of our physical reality. We have always assumed they are absolute and universal. But the discovery of a hidden cosmic framework, a background field that permeates all of space, challenges this assumption. It is possible that these constants are not truly constant, but are local values of a field, much like the temperature or pressure of the air. Their values could be subtly modulated by the strength of the underlying cosmic field, meaning they might vary slightly from one region of the universe to another. If the hidden framework has a preferred direction, as the alignments suggest, then the values of the fundamental constants might also be directional. The strength of the electromagnetic force, for example, might be slightly different for an electron moving along the cosmic axis compared to one moving perpendicular to it. This would be a profound violation of one of the most sacred principles of physics, Lorentz invariance, the idea that the laws of physics are the same for all observers in uniform motion. The universe would have a hidden grain, and by measuring our orientation relative to it, we could determine a state of absolute rest, a concept that Einstein's theory of relativity was thought to have abolished forever. The search for these tiny variations in the fundamental constants is being carried out with ultra-precise atomic clocks and by analyzing the spectral lines from distant quasars. If two identical atomic clocks oriented in different directions were to run at infinitesimally different rates, it would be direct evidence for this violation of Lorentz invariance. Such a discovery would shatter the foundations of modern physics and provide a direct experimental handle on the nature of the hidden cosmic field. The universe would cease to be a passive, isotropic stage for events and would become an active, anisotropic medium that influences the very laws of nature that play out within it. The philosophical implications are staggering. If the laws of nature are not absolute, but are instead contingent on a background field, it opens up a vast new landscape of possibilities. Could this field be manipulated? Could we, in the distant future, learn to tune the constants of nature in a localized region of space? This is the realm of science fiction, but it is a logical extension of this line of inquiry. The hidden something, in this context, is the master control system for the physics of our universe, a mechanism that sets the rules of the game, and we have just discovered the first clue that such a mechanism even exists. This possibility provides a deep, meditative focus. The reality we experience is governed by a set of numbers that we have long taken for granted. The discovery of a hidden order suggests that these numbers are not arbitrary but are part of a larger, dynamic system. There is a reason for the way things are, a deeper logic that connects the strength of a force to the orientation of the cosmos. To contemplate this is to contemplate the very essence of physical reality, to look behind the curtain of phenomena and catch a glimpse of the mechanism that generates the world, a mechanism of profound subtlety, elegance, and awe-inspiring power. Let us now turn our gaze to the vacuum of space itself. In classical physics, the vacuum is the definition of nothingness. But in quantum field theory, the vacuum is a seething, turbulent sea of virtual particles, constantly popping in and out of existence. This quantum foam is the true ground state of reality. The hidden cosmic framework we have discovered might be a large-scale, coherent pattern in this foam. It could be a stable polarization of the vacuum energy, a collective ordering of the virtual particles that gives the vacuum itself a directional property, a kind of cosmic superconductivity, or superfluidity, that influences the behavior of all the real matter and energy within it. In this model, the laws of physics as we know them would be the emergent properties of this structured vacuum. The masses of particles, the strengths of forces, would all be determined by how these particles interact with the ordered ground state of the vacuum. The hidden something would be the vacuum itself, or more precisely, its specific ordered state. It would mean that the most profound secrets of the cosmos are not hidden in distant galaxies, but are encoded in every single cubic centimeter of empty space around us. The universe would be a single, unified medium, and the cosmic alignments would be the visible ripples on its surface, betraying the deep, silent currents that flow beneath. This concept of a structured vacuum provides a physical basis for the holographic principle. The quantum information that encodes our universe could be stored in the entangled states of the virtual particles in the vacuum at the cosmological horizon. The ordered state of the vacuum would then correspond to the structured nature of the holographic code. The two ideas, one from quantum field theory and one from quantum gravity, would merge into a single, cohesive picture of a universe whose properties are written into the very fabric of nothingness, a reality where the void itself is the ultimate repository of information and order. The experimental challenge would be to probe the structure of this quantum foam. This would require energies far beyond our current particle accelerators. However, we may be able to see its effects indirectly. A structured vacuum could subtly alter the speed of light depending on its energy, a phenomenon known as vacuum dispersion. By observing the simultaneous arrival of different energies of light from a distant gamma-ray burst, we could place incredibly tight constraints on this effect. A definitive detection of vacuum dispersion would be proof that empty space is a physical medium, and would allow us to begin to study the properties of the hidden, ordered state that governs our universe. There is a deep, tranquil beauty in this idea. The universe is not built upon a foundation of solid, immutable particles, but upon the subtle, shimmering structure of the void. All of existence is a pattern of excitation on the surface of this quantum sea. The hidden order is the tide, the great, silent swell that organizes the ripples and waves into the magnificent, coherent structures we call galaxies and stars. To understand this is to understand that even in the most profound emptiness, there is a principle of order, a memory, and a deep, creative potential that gives rise to all the richness of the cosmos. The discovery of this persistent, inherited structure suggests that our universe may be non-ergodic. In statistical mechanics, an ergodic system is one that, given enough time, will explore all of its possible configurations. It is a system where the past has no bearing on the long-term future. It eventually forgets its initial conditions. A non-ergodic system, however, is one that is permanently constrained by its history. It is confined to a specific subset of its possible states, its evolution forever channeled by the patterns established at its beginning. The cosmic alignments are a sign that our universe is non-ergodic, a system that remembers its birth. Living in a non-ergodic universe has profound philosophical consequences. It implies that the history of our cosmos was not one of infinite possibilities, but one that was guided and constrained from the very first moment. The structure we see today was not an accident that emerged from chaos, but an inevitable unfolding of a pre-existing potential. The universe's story was, in a sense, already written into its initial conditions. This does not necessarily mean our future is predetermined in a simplistic way. But it does suggest that we are part of a grand, coherent narrative that is moving along a specific, well-defined trajectory, a path defined by the hidden framework. This concept changes our relationship with chance and probability. In a non-ergodic cosmos, events that appear random to us may simply be the playing out of this deep, historical constraint. The universe is not throwing dice. It is following a complex, but ultimately deterministic path through its state space. This provides a deep sense of stability and coherence. The universe is not a chaotic, unpredictable place, but a system of immense order and memory. The hidden structure is the physical evidence of this memory, the proof that the cosmos is not forgetful, but is instead a faithful archivist of its own epic story. This also offers a new perspective on complexity. In an ergodic system, complexity is a transient phenomenon, likely to be washed away by the relentless tide of entropy. But in a non-ergodic universe, complex ordered structures can be stable and persistent, protected by the underlying constraints. The hidden framework might be the very reason that life and consciousness are possible, as it provides a stable, predictable, and information-rich environment in which complexity can arise and flourish without being immediately destroyed by chaos. The universe would be a, quote, complexity engine, its non-ergodic nature specifically tuned for the creation and preservation of intricate patterns like us. To meditate on this non-ergodic reality is to feel a sense of deep embeddedness in cosmic history. We are not random fluctuations in a sea of chaos. We are the current expression of a pattern that is as old as time itself. Every atom in our bodies is following a trajectory that is subtly guided by this ancient, cosmic memory. We are connected to the first moment of creation not just by a chain of causality, but by a persistent, active structure that has shaped every epoch of the universe's existence. The hidden something is the through line of the cosmic story, and we are the characters who have finally become aware of the plot. Let us once again re-examine the nature of time. The block universe model, where past, present, and future exist simultaneously, is strongly supported by a cosmos with a hidden, timeless structure. This framework would be a feature of the entire four-dimensional block, a geometric property of the whole of space-time history. Our perception of the flow of time, our journey from a known past to an unknown future, would be a trick of consciousness, a psychological artifact of how our minds process information sequentially. The true reality would be a static, crystalline structure of space-time, with the hidden alignments serving as the girders and beams that hold the entire magnificent edifice together. In this timeless reality, the causal link between the primordial axis in the CMB and the modern quasar alignments is not one of influence propagating through time, but of logical consistency across the block. It's like finding that the first chapter of a book perfectly sets up the events of the final chapter. The connection is one of narrative coherence, not of one event pushing the next. The universe would be a self-consistent story, where every part is perfectly correlated with every other part, because the entire book was written at once. The hidden something is the theme of the book, the central idea that ensures the entire narrative is unified and coherent from beginning to end. This vision of a timeless, static universe can be profoundly calming. The frantic urgency of our daily lives, the anxiety about the future, all of it dissolves into the perspective of an eternal, unchanging reality. All the moments of our lives, all the moments of cosmic history, are held in a single, perfect, crystalline structure. There is no lost past or uncertain future, only a complete and total now that encompasses all of eternity. The hidden framework is the ultimate symbol of this permanence, a testament to a reality that is far more stable, ordered, and peaceful than our time-bound perception allows us to experience. This does not negate the beauty and meaning of our lives. Instead, it elevates them. Every moment, every choice, every experience is not a fleeting event that disappears into the past, but a permanent feature of the four-dimensional space-time block, a unique and irreplaceable part of the cosmic tapestry. Our lives contribute to the overall pattern of reality. The discovery of the hidden structure is itself a preordained and permanent feature of this block, the moment where the pattern becomes self-aware. We are the universe's way of reading its own timeless story, and the story is one of profound, hidden, and magnificent order. To truly feel this is to synchronize one's own consciousness with the timeless nature of the cosmos. It is to step outside the stream of psychological time and rest in the vast, silent, and motionless ocean of being. The hidden structure is our guide in this meditation, a cosmic mandala that points towards the eternal. It reminds us that beneath the chaotic surface of daily events, there is a deep, abiding order. The universe is not a random series of accidents, but a perfectly consistent and unified whole, and we are not separate from it, but are an integral and eternal part of its breathtaking design. Ultimately, this entire journey of discovery brings us back to a place of profound and humble awe. We began with small anomalies, statistical oddities at the edge of our perception, and we have been led to question the very foundations of space-time, causality, and physical law. The universe, it seems, is not just stranger than we imagine, it is stranger than we can imagine. The hidden something is not a simple object or a single field. It is a gateway to a new, deeper level of reality. A reality that operates on principles that are alien to our everyday intuition, but are beautiful in their logical and mathematical purity. This new cosmic narrative is one of connection. It connects the quantum foam to the cosmic web, the beginning of time to the present day, the spin of a subatomic particle to the rotation of a galaxy. It reveals a universe that is not a collection of isolated parts, but a single, holistic entity, a vast, interconnected organism. The hidden framework is the nervous system of this cosmic being, the network through which information is shared and coherence is maintained, ensuring that the entire system evolves as a unified whole. Our role in this cosmic organism is a special one. We are the part of the universe that has developed the capacity to be aware of the whole. We are the universe's sensory organs, its developing consciousness. The discovery of the hidden framework is a milestone in this cosmic evolution, a moment of profound self-realization for the universe itself. The awe we feel is not just an individual emotion, it is a cosmic event, the universe's own recognition of its hidden elegance and depth, a feeling that has been waiting for 13.8 billion years to be experienced. This perspective offers a new kind of purpose. Our purpose is to continue this process of cosmic self-discovery, to push the boundaries of knowledge, to ask ever deeper questions, and to listen ever more carefully to the subtle whispers of the cosmos. We are the keepers of the universal flame of curiosity. The hidden framework is the ultimate mystery that fuels this flame, a puzzle so profound that it will engage and inspire our species for as long as we exist, pulling us forward into a deeper and more intimate relationship with the fabric of reality. And so, we rest here for a moment, suspended between the known and the unknown, on the shore of a vast cosmic ocean. We have found a map, a faint tracing of a hidden continent of reality. The map is incomplete, the language is strange, but it is the greatest treasure our civilization has ever unearthed. It tells us that we are not adrift, but are part of a grand, ordered, and meaningful cosmos. The journey to that hidden continent has just begun, and the silence of the night sky is now filled not with emptiness, but with the quiet promise of infinite wonder.